We actually had planned to talk about aluminium, right? Which is, I think, what
Yes.
we are planning to do. But after I witnessed your seminar, I said it has to be on energy conservation because if my small foundry can save lakhs, a lot of y'all guys who are on induction furnaces can save crores.
This 40% is most likely going to change.
I think that's the big part.
That's a big part. About 70 to 75% of energy consumption in foundry is attributed to the melt shop alone. In the second line is contract demand. From here, the real show happens.
With the FoundryBiz platform, we have now decided to actively add foundry consultants all over the world free of charge. And this is because we know that Foundrymen need quality consultants if they want to grow their foundries. So by now having foundry consultants on our platform from anywhere across the world, you can connect with them, you can have maybe a Zoom call, you can consult with them, and with good quality data, it is possible for you to get a solution to your problems remote without them even entering your shop floor. That is something that the COVID era has taught us. So head over to foundrybiz.com, find and locate your preferred consultant, and grow your foundry the way that experts do. Welcome guys back to the Foundry Podcast. I just witnessed a very extensive seminar on energy conservation with Mr. Anant Bam here, who's our guest for today, right?
Hello.
So welcome on the show, right? And the reason we actually had planned to talk about aluminium, right, which is, I think, what
Yes.
we are planning to do. But after I witnessed your seminar, I said it has to be on energy conservation because if my small foundry can save lakhs, a lot of y'all guys who are on induction furnaces can save crores, you know,
Indeed.
and that's something.
It happens so.
Right. So it's really amazing. I think you guys should really stick around. So keep your bills ready because you're going to need that, and he'll be
All over India, all the energy bills are on the same platform.
okay.
The rates may vary, the tariffs may vary, but the calculation method and the methodology of generating a bill is common for all.
Is common. So basically everything that you mentioned on the bill,
Yes.
they know exactly what to look
Yeah.
for. Right. So keep your bills ready if you're all around India because this is going to be a really interactive podcast where we are going to have bills. Maybe I'll also display them on the screen and we go through exactly step to step as to what the power department is charging you and which you know some of us have not gone through dissecting our bills for your generations, not even years. So you're going to save a lot of money. Coming 1st of April, there's also a very big change in the power structure and tariffs that you're going to be paying. So that's why we're trying to release this before the 1st of April. And it's going to be something that will really change your bills a lot and save you a lot of money. Right?
True.
Because that's ultimately what
Very
founders are
true.
interested, right? Our margins are thin, so savings are are really key for us. Right. So let's just go ahead. Mr. Anant Bam, needs no introduction. In fact, he's well known around India as a consultant, even maybe out of India, and mainly on aluminium. But today it's about energy. So I wanted to ask you one question. Right?
Yes.
I'm curious about it. How long have you been working with foundries?
I'm a foundryman before my birth because my father made the first Made in India chaplet way back in 1956.
Okay.
Since then, our family is connected with foundries.
Right.
And after my graduation in 1991, I joined my father's business, although my father was no more at that time. It was a family-owned business by myself and my two brothers.
Okay.
In 97, 98, due to family agreements, I had to move ahead and left the chaplet business to brothers and started with my aluminum foundry.
Okay. Got it.
Yeah. And it was a tiny unit. I can say that at its peak, we produced about 15 tons a month.
Right.
Of gunmetal, aluminum, bronze, aluminum, all non-ferrous put together.
Correct.
And with just 6 people.
Okay. This was in the 1990s.
I started it in 97, 98.
Okay.
And I closed it in 2008, 2009.
Right.
Yeah. So I am into consultations since 2005.
Okay.
And when I was chairman of Western Region, that time with the under auspice of our past chairman Amish Panchal, this project was initiated, Urja Sanchay program.
Okay.
Amish started it in a modest way during his tenure as chairman of Western Region. I continued with his legacy and I continued it for 2 years, wherein along with Shyam Kulkarni we could cover more than 70-75 foundries.
Okay. Till date.
No, in 2014, 2015. I'm talking about 10 years ago.
Okay, just in 1 year.
Yes.
So 75 foundries just in 1 year.
Yes.
Wow, that is an impressive amount.
And we gathered a lot of data. We stratified the data. We made a comparison. That time we selected few foundries which were having 250 kilowatt panel, 300 kg crucible, making cast irons majority, making tractor parts with a bunch weight of 20 to 25 kg in a jolt squeeze molding machine line.
Correct.
So all the parameters were similar, the operating practices were similar, the casting demanded similar type of metallurgy and temperatures. So it became easy for us to compare performance of individual foundry on the melt shop.
Okay.
During that process, we found out that about 70 to 75% of energy consumption in foundry is attributed to the melt shop alone.
75%.
Yes,
Just the melt shop alone.
And that's a big number.
And this is for foundries who have also a machining division.
Yeah.
Okay.
But with a large machine shop, the figures may vary slightly, but it will come down to maybe 55 to 60%.
Okay, so
but
still a large chunk.
Then it's a larger chunk.
Correct.
So if you save something at the melt shop, naturally it has a larger saving potential.
Correct.
It's a low-lying fruit.
Correct.
Which you can pick very easily. And I don't mean that you should attain 100% efficiency. But even if you have some 5%, 10% potential to improve, that quantifies to a lot of sum.
Right.
Yes.
Agreed. So you found the saving, in fact, you also found the low-hanging fruit in energy conservation.
Yes.
That is something that directly...
So I would say that that induced the thought of doing a scientific study of energy.
Okay.
I enrolled myself with the Bureau of Energy Efficiency, underwent a program of energy auditor or energy manager. It's a 4-paper exam, all from our basics of mechanical engineering and electrical engineering. Everything to do with energy, its various ways and means, various forms, what happens during conversion from one form to another.
Correct.
And how to pinpoint the scope for energy conservation.
When was this?
I gave the exam in 2019.
Okay, recently,
yes.
6 years ago.
Yes.
Right.
I could pass the 3rd paper. That's I'm a qualified energy manager, certified by Bureau of Energy Efficiency.
Correct.
Unfortunately, at the age of 52, 53, you don't have that zeal to study in academics or excel in academics.
Right.
So I could not pass the last paper.
Right.
But I am happy with whatever I have.
Correct.
I would say there are thousands of energy auditors, qualified energy auditors who have passed the 4th paper as well.
Right.
But the purpose of energy audit, that makes me concerned. I have seen various energy audit reports from various auditors, which put more focus on theoretical things rather than practical saving opportunities.
Correct.
Your earthing pit is not as per international standards, although it is an important issue.
It's not the constraint.
It's a concern from auditor's point of view, but its contribution towards energy conservation is zero. All those reports I have seen are more from the compliance point of view.
Okay.
That whether the entity is compliant or abiding the law or not.
Correct.
But the major focus of learning energy audit is to find energy conservation opportunities. You might have seen the 3-star, 4-star, 5-star rating stickers on your consumer electronic goods.
Correct.
Fridge, washing machine, all those things have those stickers.
Right.
When you go home, you just look at the sticker. It has a logo of Bureau of Energy Efficiency.
BEE.
So, very purpose and the very name of the nodal agency is Bureau of Energy Efficiency, energy efficiency. So the focus of any audit, any energy audit has to be basically on energy conservation, increasing the energy utilization efficiency of any entity.
With whatever is already available.
Yes.
Right.
So that focus one cannot have if they lack in process knowledge. And I would say that makes me different from other auditors, although I am not an auditor.
Right, that's very important what you said, because you need to be aware of the foundry processes.
Correct.
Right.
And apart from the analysis of energy bill or analysis of any power factor or any part which is a common factor for all industries, I find that if you possess domain knowledge of the process itself,
right,
then the volume of savings, potential savings in process control is much larger than the power factor control or energy management from theoretical point of view or compliance point of view.
Correct. That's good.
Yes.
So you mentioned power factor.
Yes.
Right? I think which is the main essence of what we're talking about today. So what is power factor?
I won't go into details. You can just Google it. You will get from Byju's classes up to any physics wala. You will get all the explanations.
Right.
I would say that there is a difference of some angle by which current and voltage differ in their sine waveform. Sometimes current leads the voltage, sometimes current lags the voltage.
Okay.
So we won't go into details. Both these lead and lag lead to a reactive power, which is hampering the utilization of utilizable or active power. In vector diagram, the angle between actual power and available power is determined by theta.
Okay.
And cos theta is the power factor. So whenever you are having an inductive load, normally the power factor is lagging. Whenever you have a capacitive load, the power factor is leading.
Right.
And in case of pure resistive load, power factor is 0. The power factor is at congruence, that is 1. So there is no lead, there is no lag. Some 6-7 years ago, with Maharashtra state, the power factor penalties and incentive scheme appeared into the billing system.
Okay.
That time you have to maintain power factor above 0.9, then you get some incentive. Above 0.95, then you get more incentive. Less than 0.9, then you are penalized. Less than 0.85, you are further penalized. So that was the scheme that time. Even till date, for LT consumers, that scheme is valid, although the incentive percentages have diminished, but still that scheme is in place. With HT consumers, the authorities have moved on to kvah billing system. Now, in layman's language, I will explain both the things hand in hand to you.
Right.
Power factor plus kvah and kwh.
Is this the time when we can open up our bills?
Maybe after a minute. But
okay.
Let's
so
prepare ourselves.
Keep your bills ready.
Yeah,
right?
keep
because
your bills ready.
That time is coming. Right.
See, the purpose, in layman's language, if I am a trader, I am handing over 100 pieces of bananas to Ian.
Right.
So I am entitled to bill him 100 pieces.
True.
Ian moves from one place to another. Finally, he reaches home. In the transit, he loses 2 or 3 bananas. So he is left with 97 bananas. He wishes to pay for only 97 bananas. So whatever I delivered to Ian is whatever my electricity authority, the distribution board, delivered to me.
Correct.
At my doorstep. That is kvah.
kvah. So
yes.
That's whatever the distribution is coming to your doorstep.
Yes.
Right.
And now my operating inefficiencies, my lethargy, my spillage accounted for those 2 or 3 bananas.
Right.
So out of those 100 units kvah delivered at my doorstep, I could utilize only 97 units. That's the kwh.
Right. kwh.
Yes.
Okay.
Kilowatt hour. And
Right.
kvah means kilovolt ampere hour.
So essentially what you're trying to say is that they are delivering us 100% of the power that they are delivering
Yes.
us. And if we are able to maybe use, and our spillages maybe accounting for 97, 95%, they are still going to be billing us for 95, not the 100, right? That's what's happening currently.
Till 31st of March, that
31st of
privilege
March.
is with LT consumers.
So all that's supposed to change.
Yes. In coming days, it will change.
Right.
Even the LT consumers will have to pay for kvah billing.
Okay, so that means our efficiencies are now going to be added on to our bills.
Yes, indeed.
Our
Our inefficiencies
Right.
will be added onto our bills.
Okay, so all the
And
more that this thing is
it
important.
suits with the lean management of our government.
Right.
That why should one pay for your inefficiency?
Right, true.
You are spilling your 3 bananas, that's your problem.
Correct.
I delivered you 100 bananas, it's my privilege.
Correct.
So I should get paid for my 100 bananas.
So this is exactly why I think this podcast
Exactly.
was really necessary, because when I understood exactly what you were talking about, and when the deadline 1st April is really at our doorstep now knocking, this is the ideal time to get this out to the masses.
Very good.
So let's dive in. Let's have our bills ready.
Yes,
Right.
sure.
So we're just going to need a minute to open up our bills. So now that we have our bills ready, right?
Yeah.
Right. Now we can very clearly go over all
We
the
can very clearly
terms.
go through all the bills right from the first line itself. Maharashtra State Electricity Distribution Company Limited.
What's important here now?
So important is that billing amount,
Right.
right? You get one billing amount which is the notional billing amount or
Okay.
actual bill for the current month,
Okay.
which is the first figure what you see.
Right.
The second figure what you see is the discounted billing amount or prompt payment or early payment discount.
Correct.
The third figure which you see is the late payment penalty amount.
Correct.
So the first figure is what is the current bill actually. You have to ignore both the figures because that is the actual figure.
Correct.
The second figure, which is a smaller figure, is the discounted amount, but discount is not for your energy consumption. Discount is for your prompt payment.
Prompt payment. Right. Right. Which we always take advantage of. I
Yes.
think it's on the 10th or 11th
Yes,
of
yes,
every month.
indeed.
Right.
So we have to concentrate on the first figure.
Correct.
That's the actual bill for your current month.
Right. So in this case, it's about what, 20,960.
2960. That's
Right.
the first figure.
Okay, great. So that's the bill
That's
amount.
your
for the
actual
month.
bill amount.
Got it.
Then you move on to tariff.
Okay.
That's the code for your tariff, 36LTVB2.
Right.
So you come under LT category, that's low tension category.
Right.
And that's the code number for your location
Mm.
and which grid you are getting from.
Right. Rural 2. Correct.
Yes.
Right.
We won't go into the details of meter number, location number, activity and so on and so forth. That's very
Correct.
common to know.
Correct.
Then we see the connected load. Here it is 29 HP.
Yeah. So that's contract demand, right?
No, that's a
Connected-
different thing.
Okay, sorry,
Connected
connected
load
load,
is the total power capacity of your all your equipment.
Okay.
It may not be working simultaneously, but if you have 100 machines of 5 HP each,
Hmm.
then your connected load will be 500 HP.
Correct.
Your contract demand is something different. Your
Correct.
connected load is something different.
Got it. Got it.
Yeah. Connected load has got nothing to do with your billing amount.
Hmm. It's only basically an assumption
it
of how
appears,
much.
No, it reflects into monetary terms during your initial installation.
Okay.
Yeah.
Got it.
That time their installation charges vary around both, means as per your contract demand as well as your connected load.
Right. Okay.
Secondly, your connected load is the factor which may push you to HT.
Hmm.
So if your connected load exceeds the standard limit, stipulated limit, you will be pushed to HT connection.
Right. So what is that limit right now? Between
Usually
LT and HT?
150 HP.
150. So if
Yeah.
I go above a connected load of 150 HP, then I am pushed into HT.
Yeah.
Okay. 150 HP. Yeah, correct.
Right.
Okay.
So next comes in the second line is contract demand.
Right. And I
It
think this
comes
is the
in-
important part.
Yes. From here, the real show happens.
Okay.
Begins rather. Contract demand is 24 kVA.
Got it.
40% of contract demand is 9.6 kVA.
Hmm.
So here I would like to put some analogy. Like when you go to any function or hire a caterer, you give that person a minimum guarantee.
Or so many plates.
Yes.
Right.
So if you give a minimum guarantee of 100 plates,
Correct.
then if there is a lesser turnaround, you get only 40 guests, you are compelled to pay for those 100 plates. Are we together?
Like a minimum
Yes.
guarantee, what you said, right?
So that's the minimum guarantee, which is the 40% of your contract demand.
Okay. So 40%
So-
of, in this case, 24 would be like
9.6.
9.6. So that is,
Yeah.
I'm assured to pay, I have to pay 9.6.
You have to pay
every
for
month.
that sum come what may.
Okay.
If you use it,
or
don't
not.
use it, irrespective of that, you have to pay for that.
Okay.
The tariff for that multiplying factor is on the next page.
Correct.
We'll
Correct.
come to that.
Right.
Again, this 40% is most likely going to change.
I think that's the big part.
That's the big part. It's
Right.
most likely going to change to on the par at par with HT connections. That is 75% of your contract demand.
So now you're saying in essence, if it's 9.6 that I'm obliged to pay for,
Yes.
right? Or
So-
sorry, that I'm guaranteed to pay for.
Yes.
Correct.
Then in the upcoming tariff, it will be 75% of 24.
Which will come to 18.
That is 18.
Yeah.
So it will be your double up. From 9.6, you will step ahead to 18 with a multiplying factor of 389.
Okay. So, am I actually even using 18 in this case? Like,
No. If we move forward to the second page directly for a while,
correct.
then you can see in the bill demand is 10.
Okay.
That comes in the KW demand, but that will also change to KVA demand. That's the MD in the last column of the first table.
Correct. So that is.
So here it is
KWA.
15.
So roughly, basically, this bill is using about 15 kVA.
This there is some glitch in this bill.
Hmm.
They should be billing you by 15 kVA.
Right.
They are billing at the rate of 10 kVA.
Or the billing is less.
Your contract demand 40% is 9.6.
Correct.
So all these three numbers are different. So there is some technical glitch in your bill.
Okay.
Yeah, very soon it will get rectified, and pray to God that they don't do it by retrospective effect.
Which means the bill amount is going to go higher?
Yeah.
Okay, let's not inform them.
Because no, it will come automatically. If your
Okay.
MD demand KVA is 15,
Okay.
in the next bill from April onwards, they will be billing by 15.
Okay, got it.
It's bound to happen.
Got it.
Now coming back to the first page again.
Yeah, I think Anand, let's just stop for a second and
Sure.
explain to people. Like I know where you're going now, which is KVA is your contract demand, right? Which we are right now obligated to pay about 40%.
Yes.
Right, but you're saying that 1st April onwards,
It might go up to 75%.
75%, right? So in layman terms, like exactly what is this contract demand that the power
It's
bill is giving
exactly
us?
I said as you do with the minimum guarantee to a caterer.
Correct.
Now I explain it from the power grid or MSEB point of view.
Yeah, and how also you mentioned that it's a national loss.
Yes,
Right. Let's
indeed,
get to that.
indeed.
Right.
Say if the utility provider, that is MSEDCL, Mahavitaran,
Correct.
in this case, has put up so many transformers at every location, and you are getting your connection from one XYZ transformer. That transformer has got a certain limit of certain kVA.
Right.
So if it has got a limit of 1000 kVA, then if you compare the same analogy of a caterer, you are getting fed by a caterer who can make 1000 plates per day only.
Right.
So his capacity is 1000 plates. On the same lines, the transformer can deliver 1000 kVA. Now there is Ian's factory, there is Mayan factory, there is someone else's factory who is being catered from the same transformers. So when you say of contract demand, then till now 40% and maybe in near future 75% of the contract demand, which you are obliged to pay, but back to back they are obliged to deliver.
Okay.
So if you are made to pay 75% of this contract demand, naturally MSEDCL is also bound to deliver you that demand. That 75% of your contract demand, which comes to 18 kVA.
Correct.
They must deliver it at your doorstep on your demand.
So basically, it's sort of like reserved for us.
So it's reserved for you, and if you are using 10 out of it right now, that 8 is going west.
Right. It's a loss
Because
of the capital
they cannot deliver it to someone else.
Right.
Despite there is a huge queue asking for new connections, for new demand. But since they have assigned this demand by way of contract with you, they cannot take some demand, some kVA from here and give it to them.
Correct. Because all of a sudden, if I do
Yes.
use it, then there are no problem.
I use again the
Right.
same analogy of minimum guarantee auto caterer.
Correct.
So if there is a catering firm having 1000 plates capacity, Ian gives him order of 100 plates, I give him order of 100 plates, such 10 people put together give him order of total 1000 plates.
Right.
So his capacity is booked, the transformer capacity is booked. It cannot deliver any, it cannot accept any further demand.
Correct.
Agreed?
Right.
Now Ian somehow takes only 40 plates. I take only 50 plates. Likewise, all these 10 people put together take only 500 plates from the caterer.
Correct.
There is a queue in front of the caterer that we want 1000 plates more, we want 2000 plates more.
Correct.
But since those excess 500 plates which he has already in his possession,
right,
he cannot sell it to those people.
It's almost like selfish in a way, right? Because
yes.
So that's exactly what
we
they're
as
penalizing you for.
consumers are blocking that demand and not using it.
I think blocking is the right word. Right.
Yes.
Right.
And not using it. So some people were arguing with me that 75% of contract demand is a huge amount. Then how can we forecast of our future? Gentlemen, I would like to say that normal growth in any MSME is to the tune of 7 to 10% a year. And here you are getting buffer of 25%.
Right.
That's 2.5 years. Cool, good enough.
Correct.
And if you cannot project your forecast to that accuracy, then please, 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 it's national wastage. Wake up. You have to be competitive, and then and only then you can survive. So if you are made to pay for that excess unclaimed demand,
correct,
it's going from your pocket.
Right.
It's eroding your profits.
Right.
Nowadays, due to so many waiting connections, reducing a demand application is accepted and implemented within few weeks. And it gets reflected into your energy bill immediately from the next coming bill.
Because there's so much of a queue.
Yes. So if you apply for reduction in demand because you are paying too much demand charges, it is accepted immediately, your bill gets reduced. But again, there is a catch. Since there is so much of rush and so much of waiting and the capacity of production and distribution is restricted, in future, if you want to increase your DMD, your demand, it takes hell lot of a time and efforts.
Correct, correct, correct.
Maybe you'll have to install another transformer at your own cost for the benefit of MSEB. Things go weird.
So just to summarize,
yes.
Okay, since you mentioned that your contract demand, or in this case, is about 24, right? 40% so far is about 9.6. That means this company is obligated to pay about just 9.6, which is 40% of the demand, right? Essentially, 1st of April is going to be changed to 75%, which means this company will now have to pay 18
kVA as contract
as demand, right?
Yeah.
So that they'll be basically charged for 18, even despite the fact that they might be using 15 in this case.
Yeah.
Correct. And where is 15? 15 is where, if you scroll down, we can
on
see
the second
KVA
page,
MD.
Yeah.
Correct.
On the second page, first paragraph, first table, last column.
It was right. So about 15 is what this company is used, and they'll be starting to pay 18 from next month onwards.
Yeah.
So in this case, what would you advise? Like, should this company go for maybe a drop in the contract, or do you think it's advisable just to continue?
No, 15 is a sum very close to 18.
Right.
And since the figures are small, your demand of 6 or 7 kVA doesn't really matter much.
Correct.
Whenever there are thousands and thousands of kVA transformers.
Correct, correct.
But if this bill was replaced with someone who is having a 1200 kVA demand,
right,
and he has applied for another 1000 kVA excess demand, additional demand,
correct,
then it becomes very interesting to observe.
Then you actually have to go in and calculate.
If at that time he has already installed that equipment of additional 1000 kVA and his demand application, additional demand application is not accepted, he is made to pay excess demand charges, which are ridiculously high.
Okay.
In this case, your demand charges are 388.
Right.
In case of HT, they are already 549. And in excess demand, it touches 700.
Okay.
So just imagine you are paying 700 rupees for excess demand on 1000 kVA. That's excess demand charges. So demand management is a must. As your demand grows,
Correct.
it becomes very serious issue. Now let's quickly touch upon the power factor issue.
Right. I think
Because it
that's another
also
part.
affects your power consumption.
Correct.
And that's going to play a major role because this demand, 75% contract demand, it may happen, it may not happen, it's a proposed thing. But it's for sure that for LT consumers from 1st April, the billing will move on to KVAH billing. Till now, LT consumers are billed by KWH billing pattern. So hereinafter it will be KVAH billing. Like I said, whatever is delivered at your door and whatever you are able to utilize out of it,
Correct.
the difference between them is power factor.
Right. So how much exactly
in this particular case, you can say that KVAH, that's the first table and the second column, 2045.
1 second. KVAH. Okay. Yeah.
So 2045 units were delivered by Mahavitaran at your doorstep.
Correct.
Through your equipment and its power factor, you were able to utilize 1647 out of it.
Right.
That's KWH.
So it's a very big loss there.
Very big loss.
Okay.
So it's about 25% here. And it reflects in your power factor, average power factor. That's the second table, second line.
Yeah.
0.83.
Okay.
So if you move on just ahead to the right hand side of the table,
Correct.
demand charges, wheeling charges, energy charges, so on and so forth, you can see that PF penal charges.
Correct.
Or oblique PF incentive. Since your power factor is less than 0.9, you are penalized by 743 rupees 70 paisa.
Right.
So that's the importance of power factor. Once you move on to KVAH billing, this power factor incentive and power factor penalty column or row will vanish.
Okay.
Because for a utility manager, MSEDCL, power factor is your internal issue.
Right.
They are not obliged to measure it either. Once they start billing on KVAH, this much is delivered to you, you pay for this. End of it.
Right.
Whether you use it or you waste it, it's your baby.
So then we have to basically work on the efficiency to make sure we're consuming less.
I would say that you are using it in appropriate manner. Power factor loss is nobody's benefit. It's national loss. It's going haywire. It's not with anybody. The utility is not benefited. The consumer is not benefited. This difference between 1 and 0.83.
Correct.
That's 27% difference. No, 17% difference. The 17% difference is everybody's loss. So now MSEDCL will be recovering that loss from consumer because KVRH lag and KVRH lead. You may see again the first table.
Right.
Your lagging reactive power is 1097 kVAR. Your leading reactive power is 29.
29, right.
So that means your capacitors are outdated. Your inductive load is high and your capacitors set to balance it are inefficient, or maybe they are less in number, less in kVAR rating.
Right.
So if you improve your capacitance, if you improve the response time of those capacitors, if you have multiple capacitors in parallel with separate auto switch modes, then this RKVAH lag will reduce. Then your power factor will improve. And there are cases where difference between KVAH and KWH is less than 0.3, 0.2%. In this particular bill, the difference is about 25%.
0.2 and 0.3 and you're talking about 25%.
Yes.
So clearly this energy bill is inefficient.
Yes.
Right.
So guys, concentrate on two things immediately:
Right.
your demand management, and second, your power factor.
So just to summarize, if I were to maybe add capacitors in this case, right, and to bring that to maybe 0.2, 0.3, and also bring the power factor load from saying from 0.8, I think it was, right?
Yeah, 0.83 to
about
0.999.
Right, 0.99. How much exactly can this energy bill come down to, like in figure numbers? From say 21
right
to
now,
30,
right now you will be saving on the PF penalty, that's 743.
Right, so that gets waived
Point
off.
number one.
Correct.
Most likely, if you touch 999, 0.999,
Right.
you will get an incentive to the tune of maybe 700 to 800 rupees.
Okay, so that's
So
1500
it's a
bucks.
net benefit of 1500 rupees.
Right.
Compared to your total bill. You calculate a percentage and let me know.
Right.
But this is for the existing scenario. From 1st April, they are not going to charge your electricity bill on 1647 units.
Okay.
They are going to charge on 2045 units.
Right.
So straight away your energy bill will increase by 25%. Because they are not going to bill you on what you use. They are going to bill you what they deliver.
Very big change.
Yes.
So I definitely think that this was really valuable, like going through this bill, especially with the way that we can now present the bill on screen, going through all these, ratings one by one.
Yes.
And make the audience understand completely. So this has been really amazing. What would you think the key takeaways?
Key takeaway is that nobody is going to pay for your inefficiencies.
Correct.
Hereinafter, you are responsible for your inefficiencies and you will be paying for it.
Correct.
And loss in power or a poor power factor is a national loss, and country like India, which is dreaming of becoming a third largest economy, it just cannot afford it.
Cannot afford it, right?
Yes.
Right. Because already, I mean, the power grids are struggling, especially with the electric vehicles and everything. Where's the new power going to come from?
New power is coming from greener fields,
right?
Solars and windmills.
Right.
A lot of solar farms and wind farms are being installed. You might have heard of the Adani big solar plant in Rajasthan.
Right.
So India had a target of producing 50% of its total energy through green route or renewable energy by 2030. It was a promise given to international community, and we will be achieving it much earlier. We are already 40% plus.
From green energy?
Yes.
Wow, that's a big number.
It's a big number. And for those who are exporting European Union, EU, now there is a big system of accounting, which is carbon footprint accounting and
right, which is something that you are actively working on.
CBAM compliance.
Right.
And that's going to make you dance.
There's a lot of fun coming in.
There is a lot of fun coming through it.
Right.
And nobody knows nothing.
Right.
Even the buyers are also quite in dark. But the moment it hits, it's going to hit very hard.
Correct.
So the only way out is green energy, green manufacturing, and fossil fuels we have to forgo.
Correct.
By 2070, we have to be net zero. That gives us 45 years.
Right.
You may say that it's quite a long time. But for a community which took 75 years to understand where to shit.
Exactly.
45 years is a very small
amount. Right. It's basically one person's working career.
Yes.
So the people who are going to make it happen right now are in their 20s right now. Right. So if you're young, listen up, because you're the ones to basically, make all these compliances happen, make our country greener, right, and put into effect all the compliances that are going to be required.
Yes.
To achieve this milestone. So in closing, like you went over this bill from this company, right, there must be a lot of people in the audience who would request that maybe you can spend a few moments of your time going over their bill, showing them where the savings are, and where the inefficiencies are, spotting them out, and exactly like you mentioned, like put a capacitor, make sure this power factor reading comes down, so you'll get an incentive instead of a penalty. So that's something that the audience might be looking for.
Yes.
So if you guys are looking for that, Mr. Anant has volunteered to get this done. So he will be doing these audits on Zoom via about 30-minute slots, right? So if you guys are volunteering for that, there's a link going to be in the description below. Quickly just click it, go onto the link and sign up with Anant for that 30-minute very quick audit. It's going to be at a very subsidized rate, basically, because he genuinely wants to help out the Foundry community.
Yes.
Right. Although it can help all communities, but he is specialized with foundries, right?
It is.
Particularly because...
But analysis of energy bill is applicable to anybody.
Right.
Yeah. Any manufacturing sector can go for it.
Correct.
If you want to go for a detailed energy audit, then my specialty, my foray is in foundries.
Right.
Yes.
Right. Particularly also because he mentioned that he started working with foundries before he was born. So, so I found that really cool. It's been really amazing having you, Audit. And I hope we can have you for seconds with the aluminium part that we decided, right? Because aluminium is your strong part.
Yeah.
Right. And also after that on CBAM, hopefully in the future.
Sure.
Right. So that's going to be really amazing. Thank you, Anand, again. Thank you for coming to Mumbai and delivering your amazing seminar. All the best for the next 2-3 days.
Yes.
And,
thanks, Ian, for giving me this opportunity to put forth my thoughts on the Foundry podcast.
Definitely.
All the best to you, this channel.
You'll be helping a lot of people. Thank you so much. So instead of looking around for a gift to maybe give your fellow Foundryman, why not give them this video instead? Because you'll be saving them a couple of lakhs and in some cases crores as well. Right. So thank you, Anant.
Yeah.
Lovely seeing you, and we look forward to seeing you on the next podcast. Thank you.
Thank you.
45 years.
Yeah.
Okay, roughly.
35, na?
45.
35.
2070, right? 2030 plus 40. 2070.
Okay. 45.
45, no?
45.
Okay.
Right.
Bro, cut the whole thing out. I think you start again with the by 20.